everyone, welcome back to Life Technologies YouTube channel. I hope you're doing well and thank you so much for watching this episode. So this is another session of our Juniper Lab simulation series. Remember that in this series we demonstrate to you how to configure, how to implement and troubleshoot different networking protocols or different networking technologies on Juniper routing and switching devices. So if you are struggling with the Juniper CLI, you have not interacted with it for a long time and you want to learn how to manage these devices, how to configure different protocols like OSPF, ISIS, BGP, MPLS, and all the other technologies on Juniper routing devices, kindly check out the previous sessions on this series. And again, just a kind reminder that if you are watching this session but you are yet to subscribe to our channel, kindly support this channel by hitting that subscribe button. Also remember to like, comment, and share this video with your connections. So in this session, we will be discussing how to implement BGP signal LDP pseudo wires on Juniper MX devices. So we know that L2 VPNs plays a very important role on service provider networks. So you've deployed your service provider network using Juniper devices across different regions, and then you have enterprise customers that want to carry their services using your infrastructure. So you will end up having to deploy some L2 VPNs or L3 VPNs so that you are able to carry their services on your network infrastructure that you've already set up. So as a network engineer, you really need to understand how to implement the different variants of L2 VPNs on Juniper devices. Remember also that we've already discussed how to implement these technologies on Huawei. We also demonstrated how to implement L2 VPN on Nokia. So if you haven't watched those videos on our channel and you want to know how to implement L2 VPNs on Huawei, how to implement L2 VPNs on Nokia, kindly check out the series on this channel. So when we talk about FEC 129, that is a very common technology where we are using BGP and LDP to build our L2 VPNs. So BGP will be used to auto-discover the remote PEs. So remember, you have the customer devices connecting to different provider edge routers. And you have to auto-discover these remote PEs. So we are using BGP as a protocol to do auto-discovery of the remote PEs. And then we are using LDP to now establish the pseudo wires or the VPWS, virtual private wire service. These are point-to-point connection across the network to the remote PEs. So we are using BGP for auto discovery. We are using LDP for establishing the pseudo wires on the network. So the benefits of this FEC 129, of course, we have scalability because we have BGP auto discovery that will allow automatic discovery of the remote PEs. So we are reducing the amount of manual configuration that we need to do for these devices to manually discover the remote PEs. So we are using auto discovery and BGP is used for that purpose. And then, of course, we are using LDP for the signaling. So we've already talked about LDP. This is label distribution protocol, and it will be used to distribute the MPLS labels that we want to be used when forwarding traffic from the remote CE to the local CEs and vice versa. So this is what we'll be demonstrating in this session, just to help you understand how to implement BGP signal LDP pseudo wires on Juniper MX devices. So again, whenever we have such kind of lab simulation, we need to do some basic configurations. We need to configure interface IPs. Remember that we have our MPLS backbone. You need to implement an IGP so that you can have connectivity from different PEs, and then you also need to configure MPLS. Remember, this is a VPN and we should be using MPLS and LDP. So you need to configure MPLS, you need to configure LDP for the label distribution. You also need to establish BGP peering session. Remember, in this session, we are implementing BGP signal. So we need to establish BGP peering session between P1 and P2 so that they are able to exchange the L2 VPN information for the local connected CEs. So once we've done that, we also need to configure L2 VPN instances. So we've been dealing much with L3 VPNs. instance. So we need to configure the routing instance for L2 VPN, and then we'll complete by configuring the CEs so that we can confirm and verify that we have connectivity between the different devices. So the symbol topology, as you can see, we have two CE devices, CE1 and CE2. So CE1 is connecting to PE01, which is in our MPLS backbone, and CE2 is connecting to PE02. And then we also have the P, the provider router, in our MPLS backbone that is connecting the two PEs. So you can see the IP address that have been assigned from the loopback IPs to the point-to-point IPs. So we can dive into the configurations and do the configuration step by step, just so that you understand how to implement it step by step. So the first step that we need to do, we need to configure IP addresses on interfaces on all routers in the MPLS backbone. So the routers in the MPLS backbone, of course, we have PE01, PE01, and PE02. And we've already done these basic configurations even before when we did the other lab simulations. But again, just a quick explanation for this configuration. So we are starting by setting the host name. Always a good practice to set the host name. And then we go ahead to configure the interface parameters. So with the interface parameters, we are able to configure the IP address, and we are also configuring the interface that is facing the customer. So remember, we have the connection to the CEs, so you need to be able to also configure the interface that is facing the customer. So you see that we are specifying the interface facing the customer as Ethernet CCC, so it will be able to carry untagged frames. And once you've done that, the unit should also be configured with the family CCC. This is cross-circuit connect. Once we've done that, we need also to configure the interface in our MPLS backbone. This is GE001. We give it a description. We configure the IP address, the point-to-point IP address towards P01. And then we also configure the loopback parameter. So the loopback should be configured with 1.1.1.1 for PE01. So the other routers are also configured the same. We set the host name. We configure the interfaces in our MPLS backbone for P01. This is GE00 and GE001, and we configure the loopback interface with 1.1.1.2. We do the same for PE02. So let's first start by doing this configuration. So on PE01, I'll go to PE01, I'll do configure, and then apply the commands. So should be set system hostname PE01, just so that we are able to identify it whenever we log in. And then I'll do commit. We'll do same for P01 and P02. I hope you understand these terminologies. When it comes to MPLS, we have the CEs, the PEs, and the Ps, so you need to understand them. And then for P01, we have two back-to-back connections. So P01, I'll do configure and apply the configurations and commit. And again, we go to P02. So for P02, we'll do the same, configure, and then apply the configurations. You can do the commit check, you can do show pipe compare to verify the configuration that have taken effect before you do the commit. And then the next step, we need to configure OSPF on all routers in the MPLS backbone. So in this lab, we are using OSPF as our IGP. You can use ISIS, you can use RIP, whichever protocol you want to use. Then you will be able to, the goal is to ensure that we have reachability between different nodes. So you can use whichever protocol that you have chosen. You can use static routing, but for this case, we'll be using OSPF. So we need to configure OSPF in area 0 and activate the interfaces. So again, we have a separate session discussing how to implement OSPF on Juniper routing devices. So if you haven't watched it and you want to practice that, you can still check out that session. and do the lab simulation so that you understand how to implement OSPF on Juniper routing devices. So I'll do the configurations on P1. Then we need to commit. Go ahead and do the configuration on P01. So as I've said, you can do show pipe compare to show the candidate configuration, and then you can do commit check to ensure that all the commands will take effect once you commit, and then finally you can commit. Then let's do P02 before we verify our OSPF adjacencies. I'll do commit. Then we should be able to verify OSPF adjacencies using the command show OSPF neighbor. So it's still two-way. Remember, OSPF has the state machine, so it will take some time before it transitions to the other stages. It will be much faster if you are dealing with the real networking devices, but this is a lab simulation, so it may be slow. It may take some time. Again, you can use refreshed. Pipe. Let me see. Let's check again. So it's now full. So we are having to adjust this towards P01 and P02. On P02, I can run show OSPF interface. I can run show OSPF route. You see that we have the routes. Again, we should be able to ping. If I do run ping 1.1.1.1, we should be able to ping the IP, the loopback interface of P1 should be .2. So you can see that we have reachability. So once we have reachability, now we can go ahead and do the other implementation. So the third step is you need to configure MPLS and LDP on all routers in the MPLS backbone. So when you are doing this configuration for LDP and MPLS, you really need to pay attention and ensure that you are activating MPLS and LDP on all the interfaces. If you miss one of the interfaces, it will really take you time to do the troubleshooting. So you need to pay attention, ensure that you activate MPLS and LDP on all the necessary interface that should have MPLS and LDP activated. So I'll start with P1. Apply the configs. P01, do the same. Apply the MPLS and LDP configurations. P02 will do the same. Apply the configurations. And the next step after the MPLS, now we need to configure BGP peering session between the PEs. And you can see that we are configuring the family L2 VPN and we are enabling auto discovery. So we need to configure this BGP peering session so that BGP will be used to auto discover the remote PEs that are having L2 VPN connections. So again, we have a separate session discussing how to implement BGP on Juniper routing devices. So you can check it out, but these are the configurations that we need. We need to configure the AS system. This is the autonomous system number of the local device, 65,000. Remember, all these are IBGP. So we need to configure the same autonomous number on the different provider edge routers. So I'll do the configurations and then we can do verification. So on P1, then do the same on P2. So we are pairing with 1.1.1.1. So we can do run BGP summary. Run show BGP summary to verify. So you can see that our neighbor relationship is established and this is BGP L2 VPN, the one that we've configured. So you can activate other families, L3 VPN, VPN v4, or any other family that you require. But in this case, we only activated the BGP L2 VPN towards the remote PEs. You can also do the same on the other side to verify that you have the BGP session up, and you can see that we have a BGP session towards 1.1.1.1. So after configuring BGP, we need now to configure BGP. We need to configure the routing instance actually. Configure L2 VPN instance. VPN instances on the PEs. So for the VPN instances, remember we are configuring instance type L2 VPN because we are carrying L2 VPN services. So you need to specify the instance type as L2 VPN. And then you can see that we are binding the interface. So the interface GE000, this is the interface that is connecting to the CE. So we have to have it in this VRF. And then we configure the route distinguisher using the type 1 route distinguishers. Then we are configuring L2 VPN ID. We are configuring the VRF targets. So the VRF targets, of course, will be controlling the route exchange between the PEs. And then one important thing that you need to do is configuring the site ID. So you can see that here we are configuring L2 VPN site. This is the local site ID. And we are specifying the source attachment circuit, the source attachment identifier. This one normally we call it SI as 1, and then the target attachments identifier is set to 2. And this one should be the vice versa of the other side. If it's not matching, then the L2 VPN will not come up. So you really need to pay attention when you are configuring these sites on your device. So if you have another site, of course, you can go ahead and do the configuration for another site. If you have 2 sites, 3 sites, you just need to do proper planning for these source attachment identifier and the target attachment identifier, the SI and TIE. And then it should be okay. So I'll configure P1. So on P1, we do the configurations. And then we do the configuration for P2. Then commit. So once we've done these configurations, now we've brought up the L2 VPNs. The final bit of the configuration is to configure the CE. So for the CE configuration, we are also establishing OSPF over the L2 VPN that we've created. So you can see that on C1 and C2, we are also activating OSPF on the interfaces. We have loopback interface to simulate a customer network, and then we'll do the verification in the next slide. So very straightforward, very easy. Set. Should be hyphen. So let me configure C1. So I'll do configure, and then paste. I'll do the configuration for C2. So once we've done this configuration, if our L2 VPN is okay, then we expect to have OSPF session established between the CEs, and they should be able to exchange the information. We should be able to do the verifications. So let's go to the verification stage. Of course, we've already verified that OSPF is okay. We have reachability. We've also verified that the BGP session is up. So let's check our L2 VPN connections. So you use the command show L2 VPN connections on the PEs. If I do it on P1, let me quit. We are not doing any configurations. So if you do show L2 VPN connection, it should give you the list of all the VPN connections that you have on this router. You see that in FEC 129, this is a routing instance that we've created. You have the L2 VPN ID. You have the local, the source attachment, the SI ID, which is set to 1. Then you have the target attachment ID, the tie, which is set to 2. And you can see that the state is up. For how long it will tell you. And you can check other details, the incoming label, the outgoing label, the local interface, it's there. So let's check on the other router, run the same command. You can also see the flags. So if you find these flags, you should be able to interpret them correctly. Maybe the L2 connection is not up, it's showing you a given flag that you don't understand. You can refer to this legend. So on P2, so again, when you are copying the configuration, you need to be keen if you copy paste any command. File quit, paste. So on this other side, you can see that for L2 VPN ID 100, local source attachment ID is 2, the target attachment ID is 1. You see that we have the type is remote, status is up, we have the incoming label, we have the outgoing label, and then you have the local interface, and status is up, encapsulation is Ethernet. You can check the routing. So you show route. When you show route, of course, you expect to be getting route from different routing tables. You see that this is our inet.0, majority connected or MPLS or connected or OSPF routes. And then we have inet.3. We have MPLS.0 routing table. We have BGP.L2 VPN. Remember, we are configuring BGP L2 VPN peering session between P1 and P2. So you can see that we are able to get this route, and you see the flag auto discovery. So it has been auto discovered. When you check LDP L2 VPN, you can also see the details. You check the routes in our FEC 129 VPLS L2 VPN that we've configured. You see that we have the routes and they are all auto-discovered. So they are BGP auto-discovered routes. So on P2, we can do the same, show route, and you expect to get a similar output. You have all these details, all these different types of routing tables from inet.0, inet.3, MPLS.0. You have BGP L2 VPN.0 and the routing instance.L2VPN.0. So this one proves that our auto discovery is okay. Also, we have established pseudo wires between the PEs. So next, you can try to ping MPLS L2 VPN. So we can ping from P1. You can also do a ping from P2. You see that if you ping, you have no packet loss, 5 packet transmitted, 5 packet received. On P2, we have the same output. You can also do a ping for the L2 VPN that we've established towards the other side. So on P1, and this is the command and the detail that you need to ensure the instance should be correct. The remote ID should be correct, and then the remote PE address also should be correct. The local ID should be correct, unless the ping will not go through. So from the other side, we can also do a ping. From P2, we should be able to ping. You see that P1 has succeeded, no packet drops. So finally, we need to check on the CEs. So on the CE, can show route. You see that we have a routes to the remote CE, and if you show OSPF neighbor, we've established OSPF adjacency towards the remote CE, so we are able to exchange the routes. I should be able to ping 22.22 via the pseudo wire that we've established, and you see that it's reachable, it's okay, and we don't have any packet drops when we do a ping from P1 from C1 to C2. So we have OSPF adjacently established over our L2 VPN that we've established on this network. So this is it. This is how you verify that your L2 VPN is well established and it can be able to carry traffic from the customer end. And these are the configurations again for the different nodes. So I hope you've enjoyed this session. So we have similar sessions on how to implement L2 VPNs on Huawei, and also how to implement that on Nokia, just to help you to understand how to implement, because the more you practice, the more you implement these technologies on different vendors, the more you are able to master how they work, their working principles, how to troubleshoot. And many times in a network, you don't just have one vendor. You could be having multiple vendors. You could be having Juniper, you could be having Nokia, you could be having Huawei, Cisco. So you need to understand how to implement these technologies on different vendors, and that's why we have been demonstrating these sessions on how to implement these protocols on different vendors. So if you are learning how to do this on Nokia, if you are learning how to do this on Huawei, and many other implementation, many other protocol, kindly check out other videos on our channel. And if you face any challenges when you are doing the lab simulation, maybe you are setting up the lab, just feel free to reach out and we'll be glad to help you. So again, thank you so much for watching this episode. Remember to subscribe to this channel, and also remember to like this video, comment, and share this video with your connections. Thank you so much, and see you in the next episode. Bye.